Hi, I am Deepak Singh. Currently, I am doing MTech in Mathematics from IIT Madras. In this session, we will explore fundamental concepts of integration, learn key formulas, and walk through practical examples to strengthen your understandings. So, let's understand what is integration. Integration is just a reverse process of differentiation. Let's go through some examples. Like if I have a function x square, now if I will differentiate it, I will get 2x. Now my interest is to go back from this 2x to normal function. So this process is called integration. Again, take another example to understand. If I have a function sine x, a trigonometric function, if I differentiate, I will get cos x. Now again my interest is to go back, so I will do integrate. So integration is just a reverse process of differentiation. If I have a function f of x, I will do differentiation and I will get f dash x. And then if I want to go back, I will do integration. So in general, if I differentiate, now let's talk about general form. If I differentiate f of x, I will get f dash x. Now if I integrate f dash x, I will get f of x, same original function, plus constant. This is the general form. Why I am getting this constant term? Let's understand why I am getting this constant term. So let me show you some examples. Like if I differentiate x square plus 1, I will get 2x. Again, if I differentiate x square plus 2, I will get again 2x. Same. Take another example. If I differentiate x square plus some constant term, I will again get 2x because differentiation of c is equal to 0. How I am doing this one? Let's go under depth. Since this is the summation, I can carry this differentiation because of distribution over sum. So I will get plus derivative of dx plus c. This by formula, derivative of x raised to power n is equal to n time n x minus 1. I will get 2x plus, this is a constant term, it will be 0, it means 2x. So derivative of this, derivative of this function is equal to 2x. So now if I want to go back for integration, so we have to add this c terms, because c may be 1, 2, 3, anything it can be have. So in general we have proved that f dash x, if we integrate, then we will get f of x plus c. Now how to show this integration. So there is a curve like this, and then we will write this function f dash x, and we have to integrate with respect to x, so we will write dx. So this, it will show we on what with respect to I have to integrate, and this is a curve, it will show integration, and it will show we have a differentiation f, and I have to do integration. So general form it will be f of x plus c. So now, so we have understand the definition of integration. It has many applications in finding areas. Let's discuss its applications. Its applications are in like finding areas. I will show you how to do this. Second, finding volumes. That is solving real world problems. So we will see how we will do this part. Now let's understand the types of integrals. Types of integration. There are mainly two types of integration. First is indefinite integral, and second is definite integral. Let's understand this one by one. So as name suggests, indefinite and it is definite. So what is the symbol? Let me define symbol also. Like there is symbol like that, this f of x dx. There is no upper limit or lower limit on this curve, but here we have a to b f of x dx. Here a is called lower limit, b is called upper limit. Since we have upper and lower limit, that's why it is called definite integral. There is no upper and lower limit, that's why it is called indefinite integral. What does this do? Let's go through some graphs. Like if I have a function like f of x, this is a function f of x, and this is a lower limit a, and this is a upper limit b. So if I want to find the area of in this limit, so this area is given by limit from a to b. This a will come here, a to b f of x dx. This will give me area of this part. And here if I have a function like this f of x, since there is no limit, so here area, we have to find the area of all the region. So how I will write, so integration f of x dx is equal to area of curve. Okay, so this area of curve is this one. So this is the basic types of integration: indefinite and definite integral. Now we have understood the difference between indefinite and definite integral. Now let's go through some basic formula that we should know. Like in differentiation, we know derivative of x raised to power n is nx n minus 1. Now I want to find integration of x raised to power n dx. So how to find this part? So let's understand the problem again. We know derivative of x raised to power n is nx n minus 1. Now I want to find a function such that if I differentiate it, I will get x raised to power n. Then this function will be called integration of xn. So how to find this? So let me help you. Take this function as a x raised to power n plus 1 divided by n plus 1. Okay, so now differentiate this function. Now if I differentiate this function, I will get n plus 1 x raised to power this n divided by n plus 1 should be as it is. Now if this will be cut out, and we will be remain with x raised to power n. So on differentiating this function, I am getting x raised to power n. Means if I want to go back, then I will do integration. Means integration of x raised to power n is x raised to power n plus 1 divided by n plus 1 plus constant term. So this is the formula. Sorry, here there should be f d of x also, because we are integrating with respect to x. So this is the first formula that we have proved. Now let's go to second formula. Integration of e raised to power x dx, exponential of raised to power x is exponential of x plus c. So we know differentiation of e raised to power x is e raised to power x. Now if I integrate, then again e raised to power x is e raised to power x. So we have proved this formula also. So till now what we have covered, first of all we understand the definition of integration is just a reverse process of differentiation. Then we did some examples to understand. This is the general form that we should understand, and in curve form, we have this general form. Then we did some applications. Now let me tell you the applications. Like if I have given a curve like this, now I want to find the area between only this part A and B. Then just I want to find this area only. So what I will do, a to b f of x dx. This is the function f of x. So to find the area in between, I will solve this part. Now if I have given this function f of x, and this a b, this c d, and I want to find the area in between this part only. So what I will do, a to b f of x dx plus c to d f of x dx. This area will be given by this part, this area will be given by this part. So in this way I can find the area in between the curve that I want. So this is the advantage, to find the area. Now to find the volume, how I will find the value? Like if I have a 3D and I want to find the volume of this part. Since this is the height, suppose this height is h. Now if anyhow I can find the area in this, then let's suppose this is the area, then volume is equal to area multiply h. So to find the area, I will calculate by integration. Multiply h. So in this way I can find the volume. So we have seen applications also now, and we have proved two formula also. So two formula basically are integration of x raised to power n dx is equal to x raised to power n plus 1 divided by n plus 1 plus c, and second is e raised to power x dx is equal to e raised to power x plus c. So this is the basic formula that we have derived till now. We have a lot of formulas in integration. We will do it later. Now let's go through some examples and solve some problems. Like if I let's solve some question. Like if I want to solve integration of x square dx. So we know this formula. So by this formula I can find n equal to 2. So answer will be x raised to power 2 plus 1 divided by 2 plus 1, x raised to power 3 divided by 3. So this is the my answer. Now let's go another question. Like if I want to find 3x square plus 2x plus 1 dx. So we can like differentiation, we can distribute this integration in summation. So we can write it like this: 3x square plus integration 2x plus 1. Now integration of 3x square, 3x, wait, let me solve again. So this is the scalar part. So we have formula like integration of a multiply f of x dx. No, let me write general formula. So in general, integration of af plus bg dx, where a and b are scalar, then we can distribute like this way: f plus b time g, where a and b are scalar. Okay, now let's solve again this problem. So 3 times x square plus 2 times x plus 1. So 3 times this, by using this formula I will get x raised to power 3 divided by 3 plus 2 x square by 2 plus x. This 3 will be cut out, this 2 will be cut out. I will be left x cube plus x square plus x plus c. So this is the answer. So I left last time, so let me stop here. So today we have explored the basics of integration, its types and its geometric interpretation. We also solved some problem to see how integration works in practice. So I want to encourage something like integral calculus is vast and incredibly useful. I encourage you to explore topics like technique of integration, applications in physics, and solving differential equations. So let me stop here and thank you for listening.